Hello dear students, and welcome to Physics 1 lab number 8, standing waves. So today we are going to investigate propagation of standing waves, sound waves in air in the plastic tube. Standing waves is a combination of two waves moving in opposite direction but have same amplitude and frequency. So we got here our tube. We will measure the moving of our sound waves. So we have here a speaker and the end of our tube and the microphone over here. So we have that rod, and we can fix our microphone here and move it inside of our tube. You will see it in the second task of the second part. So we have our oscilloscope to see the harmonic function here, and we got function generator. Make sure that your tube are closed from the left side from the beginning here. Okay. And then the first task of the part 1, our tube should be open on the end. So and then let's turn on our function generator. Okay. As you can see, we set our function generator to the 300 hertz and the amplitude is 20 VPP. So, and you have some harmonic function. You can see some picture in our oscilloscope. And now I am going to increase my frequency in function generator. And you can, okay, I am like increasing it, and you can see some changes in my picture. So we see that the amplitude in the picture is increasing. And what I should do here, I should find the position of maximum right here. Or not position, maybe frequency, range of frequency. What I should do is, I should stop at some value where my function will not change. For example, right now I'm changing the frequency, but my amplitude is not changing right here. So I should fix this frequency. That will be 341. So now let's, and change it until my amplitude will again decrease. Here. Yep. That's 346. So as you have seen, at the range of 341 and 346 hertz, my first maximum will appear. So how I will find this value? I should find the mean value of these two values, and that will be the frequency where my first amplitude will appear, or first maximum will appear. Okay, then again we will increase our frequency, and let's see our picture. Okay, we should find the next maximum. Okay. And if you see that kind of picture that I cannot see the peaks, I can just decrease my volt per division here, and I will see my picture. Okay, and I'm again increasing. Okay, and again at some value where my maximum or amplitude will stop increasing, so I'll fix this value. Okay, so right now it's 520 hertz. So now again, what I should do is increase my frequency and look at the picture. So when my amplitude will start to decreasing, I will record this data. That will be 524 hertz. So at let me turn on the output. So at the value of 520 and 524, at this range will appear our second maximum. Okay. The next thing what I want to recommend you, if you don't like this sound, this noisy sound right there, you can just decrease your amplitude here, maybe to 10 or to 5, as you wish. So, and let's go again. And we have find second maximum, and we should find third, fourth, and fifth maximum. Okay, let's go. Okay, that's our Second maximum. Or maybe let me. Okay. So I decreased the amplitude to 10 right now. Okay. Okay. Yep. Oh yeah, it stopped changing. So it's for third maximum is of 694 and just wait a minute. No, that's the wrong value. 698 and 704. So at that range is appearing our third maximum. Okay. Now let's find our fourth maximum. Okay. Okay. That will be 888 and then 892. In that range we'll have our fourth maximum. Okay, let's again change our amplitude to 5. Okay, let's increase our field per division. Okay. Yeah, that will be our 5 maximum. Okay, let me see the values. Uh, 1076 hertz and 1080. In that range we will have our fifth maximum. And then in the second task of part 1 we should do the same procedure and just close it to just fix it maybe at reach of 80 centimeters. Okay, let's start our measurements with closed tube. As you can see, it's the second task of part 1. So in the function generator we have 300 hertz and 20 volt peak to peak. Okay, press the bottom output. Okay, let's look at the picture and again we should find the maximums. Okay, that will be first maximum at the range of, okay, let's see, 322 and 326. That will be at the range of 509 and 514. So, and let's find next maximum. The third maximum will be at the value 697 and oh no, wait a minute, the wrong value. So that will be at the value of 702 and 706. So 898 and 904. Okay, let's find our fifth maximum. 1045 and then 1051. Okay, stop. That will be our fifth maximum with closed tube. Okay, then we are going to our second part. As you can see, I fixed it microphone to metal rod with tape here, and it can easily move inside of this tube. And we have metric system inside of our glass tube, and you can see the distance. You can measure the distance. In the second task, we should close our tube in the end with our piston and put it in the distance of 80 centimeters, and to change our frequency for 930 hertz. Okay, press the bottom output and let's calculate our maximums. Okay, yeah, approximately here will be our first maximum. Oh, yeah. That's the range of 6.4 and 7.6. Okay, and then our next maximum here. $24.1 and 25.3. Okay, 42.1 and 43.5. So next maximum. That will be 62.1. 62.1 and 63.4. Yeah, that will be our last maximum. Stop. That's all for today, guys.